Hello everyone, welcome to this online course of manufacturing processes. I am Kishore, Assistant Professor in the Department of Mechanical Engineering, MLR Institute of Technology, Hyderabad. As we are coming to the end of this course, okay, we have already discussed casting in detail. Also, we solved a lot of numericals. Previous year, gate numericals based on that one. Then we took welding and we covered all the welding processes almost in detail, and also we solved few numericals based on that. Now in this last section we are doing sheet metal forming. Sheet metal forming already we have covered bulk deformation. In that in detail we studied about the rolling processes. We also discussed extrusion process and forging process, which is there in this course, and also we saw a few numericals based on that. Last lecture we saw what is sheet metal forming. In continuation of this metal forming operation, we saw sheet metal forming, and we saw also in detail deep drawing and different stages what actually happens in that. Now in this lecture, today lecture, I have brought few numericals that previous year asked, gate numericals based on sheet forming, to make students aware about uh, the concept what we have studied in the previous lecture, how we are going to utilize to solve the numericals. And today will be the last lecture of this video lecture series. So we are going to complete this course today. So we'll try to take a few numericals based on this sheet metal forming. So we'll start with, as we discussed last class, how to calculate the punching force. So we'll start with the punching force, how to calculate. We have already seen the formula how to calculate. So today we'll solve few numerical based on that and try to clear that concept of the numericals. So what we are going to discuss, we have taken this first numerical. It's a very easy numerical if you understand the concept that we discussed last class. So it's a very easy numerical. You just have to apply the formula that we discussed, and after that easily you can calculate what has been asked in this numerical. So just see this one: a disc of 200 diameter. There is a disc, its diameter is given, it is 200 is blanked from a strip of an aluminium of thickness 3.2. There is a strip of aluminium. From that we have blanked out, means we have punched out a disc whose diameter is 200 Okay, the material shear strength to fracture is 150 megapascal. Shear strength of the material is given, that is 1 megapascal. What we have to calculate? We have to calculate the shearing force or the flanking force in kilonewton. Okay, so in kilonewton we have to calculate how much force will be needed to blank out the disc shape from this aluminum shape. So what we'll do, first we'll write what are the things given in this numerical. So what are the given in this numerical? Diameter is given. Diameter is given, which has been actually blanked out or punched out. What is the diameter of this one? It is 200 We are not changing the unit. Why we are not changing? Once we'll solve this, it will be clear to you. So this diameter is 200 Then the thickness of the sheet is given, or the blank is given. From that it is actually blanked out. So that is given. What is the value? It is 3.2 So it is 3.2 Then the shear strength of the material is given. It is 150 megapascal. So what is shear strength? If we are representing shear strength by this tau S, so the shear strength is given 150 megapascal, and this megapascal we know can be written as 150 Newton per square. Okay, it can be written. This mega 10 to the 6, we know if we will convert in meter, we'll have to multiply by 10 to the minus 6. So that will go in numerator and it will become simply 150 into 10 to the 6 Newton per meter square. So this megapascal easily we can write Newton per square. That's why we have, as I told you, that is the reason I'm not changing the unit. Okay, so now what will be the force? We know what this force, blanking force FB, will be equal to, we know the formula, shear strength of the material, that is tau S, perimeter of the part that we are going to blank out into thickness of the blank, that is T. So all the terms are given. What we have to do, we just have to put the value. So what is shear stress? The shear stress is given 150 Newton per mm square into what is the perimeter? Perimeter of a circle we know it is pi into d. So it is pi. And what is the diameter? Diameter is given. It is 200 mm into we have the thickness. It is 3.2 mm. This is 3.2 mm. So this is mm square. So this will be cancelled out. That's why we didn't change the unit, because automatically it will be cancelled out. So finally what we are left with, 150 Newton into pi into 200 into 3.2. Once we'll multiply this one, so I'm not going to calculate this one directly, I'm writing the value. So it will comes out, actually final this result will come out 3.301.5 kilo Newton. That will be the final answer of this numerical. So what is there in this numerical? There is nothing special about this numerical. The only thing you have to keep in your mind, and what is that what is the meaning of this blanking or punching force, and how to calculate this one, means what is the formula for that one. Once you know this one, after that whatever the shape has been blanked out, or whatever the shape we have punching out from the blank or the sheet, that perimeter we need. Once we got that one, after that we just have to put the value and we have to do the calculation very easily. We are going to do this one. Okay, so we'll move to the next numerical. And what this next numerical is, this is the second one. Second numerical, what is this? A rectangular hole of size 100 mm by 50 mm. This is a rectangular shape. Suppose this is the rectangle. This is 100 and this is 50. Now is to be made on a 5 mm thick sheet. Means we have a blank which thickness is given, T is equal to 5 mm. Okay. Having ultimate tensile strength and shear strength. Sorry, EAR. And shear strength of 5 megapascal and 300 megapascal respectively. Means the sheet from which we have to create this rectangular shape is having ultimate tensile strength UTM, that is 500 megapascal, and shear strength is given 300 megapascal. These two things has been given. Okay, the hole is made by punching process. Okay, another thing is neglect the effect of clearance. Calculate the punching force. So again we have to calculate the punching force. So what is the question? The question is, we have a sheet actually, and from that, it's a long sheet suppose. From that, what we are doing through punching operation, we are punching out a rectangular hole. Okay, na, this rectangular hole, and dimension of this rectangular hole is given. What is the dimension? It is 100 mm by 50 mm. So its dimension is given. Now that material ultimate tensile strength and shear strength is given. What is that? Ultimate tensile strength is ultimate tensile strength, that UTS is 500 megapascal, and its shear strength is tau s is equal to 300 megapascal. Then we have to calculate how much force we need to punch out this rectangular hole. So we know the formula, punching force FP is equal to shear strength of the material times what is the perimeter of the hole that we are punching out. So it is rectangular here. So perimeter of this one into what is the thickness? That is the thickness of. So if we are writing this one A and we are writing this one B, so what will be the perimeter? This A, 2 times of A and 2 times of B. Okay. So we can write here tau S into 2 times of A plus B. We can write this one. And then the thickness of the blank from which we are going to produce this one. That's it. After that, we just have to put the value. What is the value of tau s? It is given shear strength 300 megapascal. It is given in the problem. What is the value of A? It is 100 mm. And what is the value of B? It is 50 mm. So just after that we have to put the value. Again we are not going to change the unit because again it will be cancelled out. So the shear stress is given 300 megapascal. So it is nothing but Newton per megapascal is nothing but Newton per mm square into 2 times. And what is this value? A plus B. So it is 100 plus 50 into thickness is 5 mm. Okay. So after that, this is also mm, this is also mm. So this mm it will be cancelled out, and this mm square here it is 100 mm. Let me erase this one. Let me write the unit also. So this 200 mm plus 50 mm. So it will be cancelled out. Okay, and into 5 mm. So finally it will comes out 300 Newton into 2 into 150 into 5. So finally once we'll multiply this one, it will comes out 450 kilonewton. That will be no final answer. So the force required to punch out this rectangular hole from that particular blank or particular sheet will be equal to, this will be 450 kilonewton. So that's quite easy. The only thing is the last numerical that we solved, we it was that blanked out part was sort of a disc shape. Okay, na? In this one it is a rectangular shape. So what is the difference? The difference is only in the perimeter. In that case it was pi into d because it is circular shape. So it is what, pi into diameter of that circle. And here as it is in rectangular shape, so that's why we have written this perimeter 2 times its length plus its breadth. Okay. Now the next numerical is, this is the third one. Okay, for punching a 10 mm circular hole and cutting a rectangular blank of itna mm from a sheet of 1 mm. So this is the rectangular hole and this is of course of circular. So we have a blank whose thickness is given 1 mm. From that both thing we are doing. We are punching out a hole which is having circular shape, whose diameter is given, it is 10 mm, and then we are punching out a rectangular shape. Okay, now dimension also given is 50 by 200 mm. Okay, what is the thickness? The thickness is given 1 mm. What is the material? It is mild steel. So shear strength is given 250 megapascal. What we have to calculate? First we have to calculate what will be the size of the punch. Then we have to calculate what will be the size of the die, and then of course we have to calculate what will be the force required for the punching. So we are punching here, so that we have to find out. Okay, so how to calculate this one? It's quite easy. Already we have discussed how to calculate this one. The size of the punch will be the size of the hole. So what is the size of the hole? It's already given 10 mm. So what will be the punch size? The size of, if you are writing this A, the size of punch will be equal to the size of hole. And what is the size of hole? It is simply 10. That's it. Quite easy. Okay. What is the second one? What will be the size of the die? So that also we know how to calculate. So size of the die is equal to simply hole size plus 2 times of clearance. Okay, and how to calculate clearance? This C we know is clearance. Okay, so how to calculate clearance? We know the formula. C is equal to 0.0032 into thickness into a square root of shear strength of the material. We know the formula. So here shear strength is given, so we can calculate from here. Okay, or directly this value we can place here. So what will be the value? Now let me put this value here. Now what we have to calculate? Size of the die, that is size of the die will be simply equal to whole size plus 2 times, and what it will be, 0.0032 into thickness. What is the thickness? 1 mm it is given, sorry, 1 mm into under root, and what is the value of the shear strength? 250. So that will be the final value. So what after that, you just have to calculate this one, you just have to put the value. Let me go on the second page. So what will be the size of the die? Size of die will be equal to simple size of hole plus this 2 into c means 0.0032 into 1 thickness into under root 250, which is given. So this value is 10 plus 2 into 0.0032 into 1 under root 250. That's it. Once you will put the value and calculate this one, the value will comes out 10.099 mm. Directly I'm writing the value. Once you will calculate this one, we are going to get this value. Okay. What is the C? We have to calculate the punching force. So already we know what is the formula for the punching force. Punching force, we know the formula. What is the formula? Shear strength, sorry, that is shear strength of the material, that is tau s into perimeter into thickness of the blank. Okay, just put the value. What is the shear stress? It is given in the problem. The shear stress is 250 megapascal. So just put the value. 250 megapascal means Newton per mm square into what is the perimeter? The circular disc. Okay, so it is pi, and what is the d? Diameter is given 10. So it is 10 mm. Okay, let me write here. F is equal to 250 Newton per mm square into pi into 10 mm into thickness is 1 mm. That's it. After that, this mm square, mm will be cancelled out. So finally, it will comes out 250 into pi into 10 into 1, and the value will, final value will be 7.54 kilonewton. That's it. That will be the final answer. This much of punching force will be required to actually punch out a circular disc from there. Stop this lecture here, and this is the end of this course. Thank you.